So today we're going to be talking about ratios and applying those to similarity of figures so that we can identify whether the figures are actually similar or not. So they start us off with a little warm-up here, asking us to simplify the two ratios given. So the first ratio is 81 centimeters to 3 centimeters. So we always put the first thing listed in the top of our ratio. So this would be equivalent to saying we have 81 centimeters over 3 centimeters, which we would just simplify to 27 over 1, or you could also write that as 27 to 1, and this would be the ratio simplified. On number 2, they already have it written for us as a fraction. So we've got 9 feet over 15 yards. Okay, so the first thing we would need to do is be sure to convert into the same measurement. So we know that there are 3 feet in 1 yard. So if I divide my 9 feet by 3, that should convert it into yards for us. Okay, so this would actually be equivalent to 3 yards over 15 yards, now that we have them in the same measurement. Okay, so now I can simplify it. So I would simplify both 3 and 15 by 3, which would give us 1 over 5. Or we could also write that as 1 to 5. Okay, so if we are going to set up some ratio or proportion, we are going to need them to be in the same type of measurement to do so. Okay, so a blank is a statement showing that two ratios are equal. This is a proportion. So in a proportion, if you have some A over B equal to C over D, and B and D, the two numbers here in the bottom, are not equal to 0, then they said that AD is equal to BC. So if you remember, whenever you want to solve a proportion, if you just have one missing variable, we just cross multiply and divide. So they give us a couple of examples to do that on here. It says to solve these proportions, so we would cross multiply and divide. So first I multiply this direction, I would have x times 56, which would just be 56x. And then if I multiply the other direction, 72 times 7, which would be 504. So if we want to solve for x, we would simply divide both sides by 56, and we would end up with x is equal to 9. Okay, same idea over here. So if I multiply this direction, I'm multiplying y minus 3 times 2. That means both the y and the negative 3 are being multiplied by 2, or that I'm having to distribute 2 to both terms. The other direction, we have 7 times 6, which is 42. All right, so if we were going to simplify, the first thing we would have to do here is distribute. So we would have 2y minus 6 equals 42. And in order to solve, we would add our 6 and have that 2y was equal to 48, and then divide to get that y is equal to 24. All right, in the next section, they remind us that proportions can be rewritten in several ways. So they ask us to rewrite the two proportions that they give us in this section. Okay, first thing we could do is simply just flip the fractions over, right? I could rewrite this as 11 over 22 is equal to y over x. And it would would still mean the same thing. Okay? We could also put the 11 and the y together in a ratio, and the 22 and the x together in a ratio, and then set those equal to each other. So maybe I would rewrite it as 11 over y is equal to 22 over x. So we kept our numbers there in the top, our variables in the bottom. And again, you could simply flip these ratios over as well, and it would be equivalent. So we could write this as x over 22 is equal to y over 11. All right, and we could do the same thing to this ratio over here. So first we could simply just flip the fractions over. So that would be y over 3 equals x over 2, or x over 2 equals y over 3. And then we could put the variables in one ratio and the numbers in another, and that would look like x over y equals 2 over 3. And again, we could just flip those over as well. So then that one would read y over x equals 3 over 2. You also could change the order in which the fractions were written. You could write it as 3 over 2 first is equal to y over x. Okay, so proportions, while they can be written in several different ways, can also be used in several different ways. So you can use them to make scale drawings and models for indirect measuring and to determine if figures are similar, which is what we're going to be doing today. So figures that are similar, and this symbol right here means similar, have the same shape but not necessarily the same size. So it gives us this definition over here that two polygons are similar polygons if and only if their corresponding angles are congruent and their corresponding side lengths are proportional. So the shape does not have to be the same size. One shape could be bigger or smaller than the first, but all of the angles still would have to be congruent. And it has to be enlarged or made smaller by some proportional scale factor. So for example, I have these two figures here, A, B, C, D, and E, F, G, H. Okay, so we have that angle A and E are congruent because they're both 90. And then we have angle B and F marked to be congruent as well. Angles C and G are marked to be congruent. And D and H are also congruent. So all of the angles are congruent. We then would check to make sure that all of the sides are proportional. So side AB is 6, while its corresponding side, EF, is 12. So I would have 6 over 12. This would simplify to 1/2. All right. We could do the same thing for side BC and EF. That would be 5.4 over 10.8, which would also simplify to 1/2. We could do that for side DC and HG. We would have 4 over 8, which would simplify to 1/2. And then lastly over here, we've got side DA and HE, which we would write as 5 over 10, which would also simplify to 1/2. So because these are all a ratio of 1/2, we can say that they are proportional or similar figures. Okay, so next it says to identify the pairs of congruent angles and corresponding sides and to justify our answer. Okay, so We can see right away that angles N and Q are congruent because they are both marked as 90-degree angles. So angle N is congruent to angle Q. Our justification would be that they are both 90 degrees. We could also say that angle P and angle R are congruent because they are both marked to be 63 degrees. So angle P is congruent to angle R because they are both 63 degrees. Okay? Meaning that M and T would also have to be congruent, considering that the other two angles in their figure are both 63 and 90. We could add those up, subtract them from 180 to find that both angles M and T have to be 27 degrees. So angle M is congruent to angle T because they are both 27 degrees. All right. So then we would just have to go in and mark the corresponding sides. We would have that side NP corresponds with side QR. We would have that side PM corresponds with side RT. And lastly, we would have side MN corresponds with side TQ. Okay? And then we could go in and check and see if these are proportional. So we have two sides that we can check. We've got these here, right? So my first triangle NPM is 2, while the other is 1, which simplifies to 2. The hypotenuse of these triangles, we have 2.2 over 1.1, which also simplifies to 2. So, because our corresponding sides are also proportional, we could say that triangle NPM is similar to triangle QRT. So, next we have fill in the blank, a similarity ratio is the ratio of the lengths of the corresponding sides of two similar polygons. So we may need to set some of those up here in this next section. Okay, so on number 8, it asks us to determine if the triangle JLM is similar to MPS. If so, we need to write the similarity ratio and similarity statement. So it looks like we have some angles that are already marked as congruent, so what we're going to need to do is check those sides. So we're going to set up a similarity ratio. So we're going to start with side JL over side NP. Okay, so we would have 75 over 24, which simplifies to 25 over 8. We also could set one up for side LM to side PS, which would end up being 60 over 30, which simplifies to 6 over 3 or 2. So we would not be able to say that these triangles are similar because we did not end up with similarity ratios that were equal. So not similar because similarity ratios are not equal. And the reason that we had to set them up in that order is because of the statement they made. They said side JL and NP, right? Those were the letters that they listed first, so those were the ones we had to match up. For our other one, side LM, side PS, we had to pull directly from what they had listed. All right. So on number 9, they say to determine whether the polygons are similar. If so, write the similarity ratio and a similarity statement. Well, we should already be able to tell that we have some angles that are not congruent that should be, from the way these figures are drawn, corresponding. This one's marked as 70, this angle is marked as 90, and those are supposed to be corresponding and congruent. So angle A is not congruent to angle E, so these are not similar shapes. Alright, number 10 says that the ratio of a model sailboat's dimensions to the actual boat's dimensions is 1 to 32. So we've got our similarity ratio that we should be setting up is 1 over 32. It says if the length of the model is 10 inches, what is the length of the actual sailboat in feet? So we've got that our ratio is 1 over 32. I'm going to set this equal to, obviously the top is the small portion, and the model is going to be much smaller than the actual boat, and it is 10 inches, so I'll put it in the same spot as our smaller value here, over x, which must mean that it is the larger version. So all we would have to do is cross multiply and solve. So if I multiply this direction, we get 320. We multiply this direction and we get x. Therefore x must be 320 feet. Alright, number 11 says to find the length of the model to the nearest tenth of a centimeter. So we would set up some sort of ratio to determine what our similarity ratio is. So maybe we pick the ends that should be corresponding. So we've got here and we've got here. So we got 6.3 over 1.8. This would simplify to 7 over 2. And if you couldn't see that in your head, you could always divide 6.3 by 1.8 in your calculator and then use math-inner to convert it to a fraction. Alright, so I'm looking for x here. Okay, so we put the piece from the smaller model car on top, so I would have my 7 over 2 similarity ratio is equal to x over its corresponding side of 5. Then we would cross multiply and solve. So I would have 2 times x, which would just be 2x, is equal to 7 times 5, which is 35. So we would end up with x is equal to 17.5 centimeters. Alright, number 12 says to find the value of x in the diagram if these two figures are similar. So what we might set up is side AB over its corresponding side, WX, and that would be 5 over 7. Alright, so then we would have our similarity ratio. So now we could set up a proportion in order to solve for x. So we would use that 5 over 7, set it equal to our other corresponding sides, which would be 2 over x. So then we would have to multiply, and we would get 5 times x, which would give us 5x, is equal to 7 times 2, which is 14. And then we would just divide by 5 and end up with x is equal to 2.8. Assuming that these two are similar. Alright, last problem. Says that a girl that is 5 feet tall casts a shadow 4 feet long. So we got some girl over here. Draw her some hair. She is 5 feet tall and is casting a 4 foot long shadow. Here's her 4 foot shadow. Alright? At the same time, we have a tree that is casting a 24 foot shadow, but we do not know how tall the tree is. So this is what we are looking for. So we would probably want to set something up for maybe the height compared to the shadow, or you could put shadow over height. I'm going to do our height over the shadow that is being cast. So for our girl, her height was 5 feet, while her shadow was 4 feet. For our tree, we do not know the height. So that is our unknown over the shadow, which is 24 feet. So then we would just need to cross multiply and solve. So I would have 4 times x, which would give us 4x, is equal to 5 times 24, which would be 120. And then we would simply divide by 4 and get that x is equal to 30. So that would mean that the tree